Hello student, how are you? I am Arun Sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class I will teach you the error analysis. We know the error comes when we take measurement of any substance. Now let's start about the error analysis. We know errors comes in two ways. Error comes in two ways. One comes in systematic error and another from random error. Systematic errors and random errors. Now systematic means the meaning is at that word system. The error in system. Suppose system is any instrument or group of combination of instruments. So if there is a imperfection of any instrument, then the systematic error comes. And also if we set the zero values or limit of resolution of any instrument, then error comes. So this is due to imperfection of any instrument or zero setting environment condition environmental condition, suppose temperature, pressure, humidity, etc. cause the systematic error, and this systematic error can be minimized by using the more accurate instrument, minimized by more accurate instrument. So this is systematic error. Now what is a random error? Random error, that is the errors come randomly and it is unknown in what ways the error comes, we cannot predict. That is, the error cannot be predictable or the cause of error is unknown. Random error may comes the different environment condition, that is temperature, pressure, mechanical vibration causes the randomness, or the personal error, that is if a person take different readings of any particular substance, then the measurement may comes in different result. So that is called random error, that is personal error, that is errors comes from a person. Different person take different readings of any particular substance, or any person take different readings when he takes several times reading of the substance. So this is personal errors. Now what is absolute error? So error comes in two ways: systematic error, that is due to imperfection of instrument, and random errors because its error cannot be known or unpredictable. Absolute errors. What is absolute error? The difference between true value of any measurement to the measured value. Measured value means what we take the measurement of the substance, and true value, what is the true value? Is some value is assigned of a substance. Suppose a substance, its value in laboratory, its value is assigned, that is true value. In what way true value calculate, I will show, I will discuss after some time. Of any difference between true value of any measurement to the measured value of any substance. This is a rod, and we have to calculate the true value of this. Now we take the several readings. Suppose the readings becomes A1, A2, A3, A4, etc. As the number of readings more, then accuracy accuracy of the true value will be more. Now, what way we calculate the true value? The true value is actual mean value. Arithmetic mean of all the measurements is taken as true value. Arithmetic mean of all the measurements of all the measurement is taken as true value. That is, arithmetic mean of this reading is, we know, divided by n. Now this is true value of that substance. The absolute error of the reading A1 is known as del A1. So absolute error becomes AM minus A1. That is, we have to subtract measured value from the true value. Again, del A2 equal to AM minus A2. That's way. So absolute errors may be positive and negative. Positive, it may be positive and negative. Suppose if measured value is greater than true value, then it becomes negative. If measured value is less than true value, then it becomes positive. So absolute error may positive or negative. Absolute error may positive or negative. Absolute error may be positive or negative. Now, if we calculate the mean absolute error, what is mean absolute error? We take the mod of absolute error. Mod. This is the mean absolute error. Okay. Now any reading A equal to true value plus minus, this is del AM. This is called del AM. Del AM. So this is called, this is the measurement of any substance, that is maximum. A maximum will be A plus del AM and A minimum equal to A minus del AM. This is called absolute error, mean absolute error. What is relative error? What is relative error? Relative error is denoted by del AM by A. Relative error is del AM by AM, and percentage error is into 100. Numbers with error. That means, suppose a number is 4 and this is called error. This is main value and this is errors. If we add this, suppose take a general value. Let one number is and another number is this. So this is one number and this is another number. We want to we want to add the two numbers. So this becomes now there are four values. There are four values. Plus A plus this is del A. Plus del A plus del B. This is one other value. Another value is another value is and another value is now what is the maximum error? This is the maximum error and this is the minimum error. Sorry. Now what is the maximum value? Maximum value is this and minimum value is this. Maximum value is this and minimum value is this. So we can write the x1 plus x2 as a plus b plus minus. We can write in this form, that is plus this minus this, because del A plus del B is the maximum error, so it can be positive or negative. A number is another number is, so x1 plus x2 becomes, we add the main values. This is the main value 6 plus 4 10 and we add the error. This is the answer. Now what is the subtraction of two numbers? Subtraction, again if we want to subtract, then what comes? Main value will be subtract 6 minus 4 and error always be added. That is, this is the subtraction. Error always be added. In subtraction and addition also error to be added. That is, in addition main value will be added. In subtraction main value will be subtracted. But the errors always be added. In addition, two numbers, errors in product. Errors in product or multiplication. Let x equal to AB. Let two number A and B. The product is denoted by x. Now x plus minus del x will be this. So now if we take common A from this becomes, if we take common B from this, if we take common A from this, then this becomes 1 del A by A, and if we take common B, 1 plus minus this. Now A into B is called x. Now we have to multiply this. So this becomes, multiply 1 into 1, 1 plus minus plus minus plus minus AB. Now the product of these del A into del B is very small quantity, so their product will be very small. Del A and del B is very small quantity, so errors always small quantity, so their product is also very small. 0.01 into 0.02. When you multiply this, then the result becomes less than of that number, of those numbers. So the product is negligible. This is negligible. this is negligible. So what comes here from this? Now this is negligible, so this. Now cancel x x. So what comes? 1 1 be cancelled. 1 1 be cancelled. So this becomes, so what comes here? Now there are four values. One value is, so plus plus, so there are four values comes. There are four values of errors comes. Now the maximum is this and minimum is this. So we can write error in this form. So we can write this in this form. So what is this? This is relative error of x equal to sum of relative error of two numbers. This is relative error of a plus this is relative error of b. So when the product of two terms, then relative error of that number will be sum of the relative error of the individual factors. Suppose we there are a number product of three factors, so relative error of x will be relative error of x will be relative error of individual factor, that is this. Relative error will be this. This is the absolute value. Neglect errors in division. Let x equal to ab. Now we can write x plus minus del x. That's in division. Let x equal to a by b. We can write this equal to this. Now take common. Now here take common a, 1 plus minus a divided by b, 1 plus minus del b by b. Now a by b equal to x. A by b equal to x. Minus 1. So this becomes del b by now binomial expansion. Binomial expansion. When n is negative, suppose 1 plus x whole to the power n is negative, then and x becomes now in binomial expansion 1 plus x whole to the power n is negative. If n is negative, then it becomes 1 plus nx from this. But here x is small. X means this. This is small. This is small value. So if we expand this, then x is small means x square and its higher power x cube, x to the power all will be negative, all will be 0, all will be neglected. So this becomes only 1 plus nx. So if n be negative, if n be negative and x becomes small, then this become 1 plus nx. So this is b. Now this value will be, if we multiply, then 1 minus del b by b, that is plus minus. Okay, this is plus minus. Now this becomes, from this, the applying this formula 1 plus nx, it becomes n. Here n is minus 1, so plus minus into minus 1, that becomes plus minus this. Now if we multiply this, now same way, this result is very small, so it can be neglected as product of two small number becomes small of those individual numbers. So this be neglected, then this becomes this. Now if we cancel this, then what comes? So that will be this. If we multiply, then this becomes, now this value be neglected, this value be neglected, as the we know product of two negligible value becomes more negligible than those of the two values. So we get this. So out of these four values becomes, this is one value, the four possible values are present. So out of this is maximum and this is minimum, this is maximum, this is minimum. So del x by x can be written as, so the relative error of any number in division form is the sum of the relative error of two factors, relative error of two numbers. Now errors in quantity ranged to some power, that is the number in this form. Suppose a number in this form. So to find the relative error of this number, first we take the log, taking logarithm of both sides. What comes? Log x equal to log of this. We know log a by b equal to log a minus log b. Now this, now differentiating both sides. Only differentiating. Dx by x equal to, here m and n constant, log derivative of log a is dA by a, dB by b. So if we multiply both sides plus minus, and if we write this expression in terms of fractional error or relative error, then this becomes plus minus, so minus plus, this becomes this. So there are four values. Del x by x becomes b b b minus. Four values of this becomes this. So this is maximum value and this is minimum value. So del x by x can be written as this is the answer. One problem discussed. Problem: the mass and density of a solid sphere are measured to be kg and this. This is the mass and this is the density of a body, solid body. Calculate the volume of the sphere with error limits. So solve. We know mass here given in the form and density rho in this form. So we know volume equal to mass by density. So that becomes 2, and the relative error of volume becomes, so this is the fraction division form. So we know that relative error of each term, relative error of m plus relative error of rho. Relative error of m will be 0.2 by 10.2 plus this by this by this. So volume can be written as the formula V equal to m by rho. So del V by V equal to, actually formula I apply here, plus minus del m by m plus del rho by rho. I apply this. So this is the error. So main value is this, error is this. So volume can be written is this plus minus this. You calculate this value. Now volume can be written as, what is the volume? Volume can be written as some value we write in this form. Main value plus minus error. Now what is the error? We get error from this term. We error del V from this term. So this term becomes into V. Volume becomes 2. So this is the del V. So main value will be 2. This is the answer. Next problem. Quantity is given. Percentage error of A is 1, B is 2, C is 4. Find the percentage error of X. That is percentage error of these terms A, B, C are given. You have to find the percentage error of X. Then what is the value? Now we know the power is 3, 2, and here is half. So percentage error of X will be power into percentage error of A, that is 1, plus power into percentage error of B, that is 2, plus power into percentage error of C, that is 4. So just we calculate in this way. Power into percentage error of A. This power is 2, so power into percentage error of this, plus this power is half, power into percentage error of this. So this becomes 9. So this is the answer. 9%. Calculate the percentage error in determination of in determination of time period of a pendulum. where L and G are measured with 1% and errors. So this is the problem. So solution becomes t equal to this. Here power is half, e to the power half. So we know that percentage error of t will be percentage error of L into power. Half into percentage error of L is 1 plus power is half, percentage error of G is 2. So result is 3 by 2. So percentage error of T will be 1.5%. Percentage error of T will be 1.5%. Problem 4. If the percentage error of side of a cube is 2, find the percentage error of measuring its surface area and volume. This is the question. The solution becomes surface area. We have to write the formula of surface area of this cube. Surface area A equal to 6a square, giving dA by A into 100 equal to 2. So we know the percentage error of area. This area will be here percentage error of A square. Power is 2 into percentage error of A. That is 2. This is the answer. This is the answer. Now next volume. Next is volume. Volume V is denoted as AQ. So here power is T. So percentage error of volume becomes 3 into percentage error of volume. That is 3 into percentage error of side. Percentage error of side is giving 2. So that is 6. So percentage error of volume becomes 6%. Then this is the end of the class of error analysis. Okay, thank you.